did regular linear inequalities. Okay, and then we did the compound inequalities at the and or the ors. Today we're going to move into polynomial inequalities, and then tomorrow we'll talk about rational inequalities. All right, so 2 new vocab words for you. We have critical numbers and we have test intervals. So your critical numbers are essentially for polynomial inequalities, it's just your zeros. What's another word for zeros? Intercepts or zero solutions, right? Okay. And your test intervals are going to be the open with the parentheses, intervals that are created by the critical numbers. So, if you're going to investigate your polynomial behavior so you can actually answer these inequality questions, you got to locate your critical numbers. From that, you get test intervals. In your interval, you're going to pick a test point. Kind of, if you remember, back with linear inequalities, where you would draw the line on the graph, and then you would pick a test point and do your shading. Kind of similar idea here. We're not on a graph shading mode right now, anyway, at least. And then you're going to choose an x value from each interval and evaluate the polynomial at that value, and it's going to help us answer the final question. Remember, when we're doing inequalities, you're not getting just one straight-up answer. We're getting an interval of answers, just like you saw on your homework on Friday for the linear inequalities. All right, so let's talk about how to find critical numbers, and let's talk about how to create these intervals before we actually solve one of these problems. So the first example says determine which interval is x squared minus 5 is entirely negative and entirely positive. So in order to do that, I need to find critical numbers. So how would I find critical numbers for x squared minus 5?
Plug in 0?
Yeah. Let's plug in 0 now. What did we just say the critical numbers were?
Zero.
The zeros of the polynomial. Set it equal to 0, right? And solve. So what am I going to get?
X squared is plus or minus.
Click. All right. All right. So now we're going to have intervals. They're my critical numbers. So my first interval is going to be negative infinity to negative square root of 5. Because negative square root of 5 is the smaller one, right?
Yeah.
Then we're going to go from negative root of 5 to positive root of 5. Okay, and then we're going to go from positive root of 5 to infinity. So let's chat about this for a minute. I had 2 critical numbers. How many intervals did I get? 3. So typically what you're going to do is when you find how many critical numbers you have, your intervals are going to be one more than that. Your intervals should span, again, we're in polynomials, and in general, all of your polynomials, what's the domain? All real. So your intervals are going to go from negative infinity to positive infinity. Does that make sense? Okay. So the next thing we want to do is pick an x value in those intervals, and this is where you actually need to be careful. Yes, Dylan?
Wait, so like if it's like x third, x cubed minus 5, then we'll have 4 intervals?
Yes.
Then if it's like x to the 4th, then we'll have 5.
Yes. Okay, so we want to pick an x value. I will tell you the biggest mistakes I see here is people will either pick this value here, that's not an option, right? It doesn't include root 5, does it? No, because at root 5, it's going to be 0 anyway. It's a 0. So you don't want to pick them, but you want to make sure the number you pick is actually factually in that interval. So you want to make sure you pick the right stuff. All right, so give me an x value in between negative infinity and negative root 5.
Negative 5.
Negative 5, fine. How about in between negative root 5 and 5?
0.
0. I like picking 0. It's a nice easy one. And how about root 5 to infinity?
5.
Okay. So now we're going to determine the value of the polynomial at that interval. So that means I'm going to plug it back in. So when x is 5, negative 5, what number do I get? Okay, when x is 0, I get.
Negative 5.
And when x is 5, I get.
1.
I don't really care what those answers are. What do I care about? If the answer is yes, positive or negative. So in this case, it's positive. In this case, it's negative. And in this case, it's positive. So now I can answer the question. The polynomial is negative where? What interval?
Between negative 5 and
Negative root 5 to 5. Okay? And it's positive where?
Negative infinity to 5.
Negative infinity, negative root 5. In union with root 5 to infinity. Alright, so we were able to answer the question. So there are like the little things we need to do in order to solve these inequalities. You need to be able to find the critical numbers, break down the intervals, pick test points in those intervals, and then answer the question. All right, ready to try one? All right, so we're going to solve 2x squared plus 5 is bigger than 12. It's quadratic, so if I'm going to solve the equation associated with that, how do you want to do it? Okay, so 2x squared then is equal to 7, then what? 5 by 2. And I get x squared is equal to 7, then what? Square root it. So x is equal to plus or minus. That's it.
Wait, what about it's greater? Like, what about the sign?
We're getting there. The first step is to find the zeros, right? So I've got to go with the equation that goes along with it and find its zeros. Where did the square root of 14 over 2 come from? Rationalizing. Okay. So now I'm going to make my intervals. I have 2 critical values, so I'm going to have 3 intervals. So from negative infinity to negative root 14 over 2. Okay, then we have negative root 14 over 2, root 14 over 2, and then positive root 14 over 2 to infinity. Alright, and we need to pick some x values. So in order to pick x values, what is the square root of 14 over 2? Well, what's the closest square to 14?
16.
So it's a number less than 4, right? So 3 something. What's 3 divided by 2? 1.5. So, right, it's somewhere in between 1.5, negative 1.5 and negative 2, right? So give me a number that's to the left of that. Okay. How about a number here?
0.
And then this one we'll just do. Oh, that's right. Okay. So let's go back and plug it in. So then the question is, where are you plugging it into? Okay.
Oh.
You're going to plug it in there. Okay, you have to have 0 on one side. Why would I have to have 0 on one side? What is the thing that we care about? Whether it's positive or negative. So to determine positive or negative, we need to have a 0 on one side, because 0 is the barrier for positive and negative. Does that make sense?
Oh. I think we got that.
To the left of 0 is negative, to the right of 0 is positive. So it's like the
okay.
split line.
Got it.
Alright, so if I plug in a negative 3, I get 9 times 2 is 18. 18 minus 7 is 11, and that's positive. If I plug in a 0, and that's negative. And if I plug in a 3, I get 11, and that's positive. Okay, so now I'm going to answer my question. I want to know when this polynomial is bigger than 0, which means I want to know when that polynomial is positive. So where's the positive? Okay, so the final answer to the question would be negative infinity to negative root of 14 over 2 in union with root of 14 over 2 to infinity. All right. Questions? So if,
Plus, minus, plus.
no, it just, in this specific case it was. So if, let's go over here real quick. I'm just going to quick pop it up on Desmos. And I just want to look at it graphically so you can see, like, pictorially that this is similar. What do we got? 2x squared minus 7. 2x squared minus 7. All right, look at your graph, guys. If I click here, there it is, negative 1.8 and positive 1.8. There's my critical numbers, and that matches up what we found, correct?
Yep.
And you can see, look, we're positive here, we're positive here, and we're negative here. Our inequality wanted us to find out all the spaces where we're positive, and we did get those two different intervals where the function is positive. So now you can kind of see pictorially how that algebra coincided. So you can check yourself, not on the test, because I won't give you a graphing calculator, but you can check yourself to see if you did it correctly. Does that make sense? Questions? Okay, let's do the next one. All right, this one's a trinomial. It's a little bit longer, but again, it's a quadratic. So I should get 2 zeros, which is going to give me how many critical numbers?
3.
All right. So start solving. Okay, first of all, and I'm going to move this 16 over to get 7. So I want to know when my polynomial is what?
0. Greater, less than 0.
Negative. All right, so I'm going to solve that. Can I factor it?
Yeah.
What does it factor into?
X minus minus.
So my two critical numbers are,
7,
all right, so if they're my critical numbers, what are my intervals?
negative 3 and negative 1. Negative 1 is 7. Negative 7 is 1.
Okay? Give me an x value in my first interval.
Negative 9.
How about my second interval?
Plus 0.
And my third interval? All right. So let's evaluate our polynomial. Again, you're just plugging it essentially into there.
So we have to make this box with
No,
Why negative 9?
just to help us.
why not? Yes.
So we're both.
Yeah.
Be careful because it's a middle term. So you do have to solve more than once. All right. So what? 81 minus
That's going to be plus.
54 minus 7. It's still going to be positive. Negative 81 plus 54.
Wait, where's the-
Or 81 plus 54, this is going to be positive too. I don't know what my numbers are, but I know it has to be positive. Does the number really matter? No.
Then 0.
Okay, so you can, it doesn't matter if you figure out what the value is or not. What matters is the value going to be positive or negative? So you could technically skip that step if you can plug numbers in and just say, okay, my answer is going to be some positive number, ladies, or my answer is going to be some negative number. All right, so you don't, if you're making like a chart on your papers, but I don't give you one, you don't necessarily have to fill that part in. All right, so the problem is I want to know when it's negative. So what's my answer?
Negative
When it's negative 1 to
Negative 1 to 7. Okay, and again, if you brought up the picture of that, you'd see that's where
Why
it's
were we searching for
below
negatives?
zero. By what?
Why were we searching for negatives this time?
Because I want where it's less than 0. What does less than 0 mean?
Negative.
Negative. All right. Next one. I added an or equal to this time. And it's an x cubed, which means how many answers am I getting? Which means how many intervals?
4.
Okay. So I'm looking for x cubed minus x squared minus 16x plus 16. I want to know when my numbers are what?
less than or equal to 0.
which means
Uh,
0 or negative. Good. All right, so we're going to solve x cubed minus x squared minus 16x. Yep, back by grouping. In my first group, so it's an x, and I'm left with x squared, and I'm left with minus 1. And in the second group, I'm bringing out a negative 16 to get x minus 1. So it's x squared minus 16, x minus 1, which I can actually then do.
X plus 4. X
X.
plus 4.
Oh, plus 4. X minus 4, x minus 1, which gives me
X
negative
plus or minus 4 and 1. Okay. I'll be proper here. All right. So my intervals, I'm going to go from negative infinity to, and then from negative 4 to, and then from, okay. All right, x value here. Bingo. Okay, how about here?
0,
How about here?
3.
How about here? All right, so we need to start plugging them in. And again, the more important thing is positive or negative values. So 0 is the easiest one to do. 0, you're just going to get positive. You guys tell me what I get for the other ones.
It's calculators.
Plus 16. So 1 to 4 should be
Not, well, yes, it's negative or no, it's not.
Negative 5.
if it's 3.
The negative 5 is
3 is the only one that seems to be negative.
negative 5.
Negative 5 turns out no.
25, 16, that's positive.
The negative
And the
5.
negative 5 is also positive.
Are you sure?
Yeah.
Negative 5?
Oh no.
Negative 125
Plus
minus
25.
25, that's negative 150 minus another 80.
Plus 80.
I'm pretty sure it's negative. Or plus 80, it's still negative. Do not forget, negative 5 cubed is
Negative.
negative 125. Plus 80, plus 16. These two numbers are still, it's,
Less than that. But
yeah.
Wait, so is it
Plus
possible that it has to
It's
be
plus
like plus
25,
minus plus
right?
minus?
wouldn't it be plus 25?
No, it's minus 25. Because what's negative 5 squared?
25.
25, so it's still minus. Right?
Yeah.
So this will take it to 100, negative 100, but this is still less than 100.
Negative 1.
All right, so we wanted to know when it's negative or 0. So when is it negative or 0?
From negative infinity to negative 4 in union with 4.
All right, but your final answer, and I'm going to do it in green here, because it's or 0, right? So it's negative infinity to negative 4, include the negative 4, right? Because when you plug in negative 4, what's the answer you pop out? 0. In union with, include your 1 and your 4. Okay? Question.
Then why you including it?
Because we want when it's less than or equal to. So whenever it says or equal to, make sure you include those zeros. Does that make sense? Questions on that?